right, now time for a little bit of question 5. Regular polygon E, F, G, H, I, J, shown below, has triangle OEF is equilateral and EF is 5 centimeters. It says, what is the name of the polygon shown above? Well, first and foremost, we have to notice that this has 1, 2, 3, 4, 5, 6 sides. When it has 6 sides, what's it called? A hexagon. It's called a hexagon. All right. I think 5 side is pentagon, 6 side is hexagon. All right, 7 side is septagon, 8 side is octagon, 9 side is nonagon, and 10 side is decagon. You have to remember that hexagon is for 6 sides. It has 1, 2, 3, 4, 5, 6 sides. Now it says calculate the perimeter of EFGHI. The perimeter, since it has 6 sides, it's going to be 5. This side is also 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 5. Because they have equal lengths. So 5 plus 5 is 10. Plus 5 is 15. Plus 5 is 20. Plus 5 is 25. Plus 5 is 30. And so the perimeter is 30 centimeters. That's the perimeter. The perimeter is 30 centimeters. All right. Now this right here says, determine the size of each interior angle of the polygon. Determine the size of each interior angle of the polygon. So what they're asking for is these interior angles. All right. Where are we going to find these interior angles? All right. So there's a formula to find it. The formula to find interior angle is 180 times n minus 2. That's the formula to find interior angles. All right, this gives us the sum of interior angles. So in this case where n is 6, the sum of the interior angles is going to be equal to, when you put n as 6, you get 6 minus 2 is 4. 180 times 4. 180 times 4 will give us the sum of the interior angles. 180 times 4. And 180 times 4 is 720. So the sum of the interior angles is 720. Now, if the sum of the interior angles is 720 and there are 6 sides, then what we know is that the size of each interior angle, let's call it theta. Let theta be each interior angle. Theta is equal to 720. And that is being divided by the number of sides, which is 6. So 720 divided by 6, which is 120 degrees. 120 degrees. And that's the size of the interior angle. Nice and easy. 120 degrees is the size of the interior angle. Soft. Now it tells us that show by calculation that the area of the polygon to the nearest whole number is 65 centimeters squared. To show that the area of the polygon. Now, to find the area of the polygon, right? There are many ways you can do it to find the area of the polygon. You can break it up as you can look at it as two trapeziums. This is a trapezium and this is a trapezium, and you can find the area of this trapezium and find the area of this trapezium, add them together and you're good. Or you can look at it as this as a triangle, this as a triangle, this as a triangle. Find the area of this triangle and multiply it by 6. So let's do it both ways. Any way you want to do it. Let's use the trapezium way. All right. Now, using the trapezium way, remember it's a half a plus b. We know this length from J to G is what? We know from J to G is going to be 10. How do we know that it's going to be 10? All right. Well, let's work it out first. Let's do the triangle way first, then we use the trapezium, because that's going to require more calculations. All right, so just put down what we know. We know that each interior angle is 120. So if each interior angle is 120, you will know this angle is 60, this angle is 60, and so this angle is also 60. This is the equilateral triangle, and so this is 5 and this is 5. All right, and so now we can find the area of that triangle easy. So the area of the triangle is, I'm going to use a half AB sine theta. The area of the triangle is a half AB, which is a half 5 times 5 times the sine of 60. All right, and that's going to give us the area of the triangle, and the area of the triangle is 5 times 5 times 0.5, and we multiply it by sine 60. We multiply it, so I'm getting 10.82 is the area of the triangle, 10.82 centimeters square. All right, now that the area of the triangle is 10.82 centimeters square, the area of the hexagon, I'm going to call it H. The area of the hexagon, H represent the, so I'm calling the polygon H, the hexagon H. So the area of the hexagon is 6 times 10.82. 6 times 10.82, and 6 times 10.82, as you know it, that's equal to 6 times 10.82, that is 64.92, and 64.92, that is approximately equal to 65. That's approximately equal to 65 centimeters square. That's the area of the hexagon, 64.92, which is approximately 65 centimeters square. Nice and easy. That's the area of the hexagon. 64.92 is approximately 65 centimeters square. That's the area of the hexagon. Now let's say we're using the trapezium rule. I really want to look at trapezium. What do I mean by trapezium rule? I mean just using the formula to find area of trapezium. The area of any trapezium is a half the sum of the parallel sides. It's a half the sum of the parallel sides times the perpendicular height. So it's a half A plus B times the perpendicular height H. Now, because the area of this trapezium is going to equal to the area of this trapezium, right? The area of this trapezium is going to be equal to the area of this trapezium. And when you add them together, a half A plus H plus a half A plus B times H is just going to be A plus B times H. All right, so using what we know about trapeziums, look how easy we can do this now. So all we need to do is find the perpendicular distance. All right, find the perpendicular distance. So let's find this perpendicular distance. Now this perpendicular distance, the perpendicular distance, we're going to call it H. The perpendicular distance H is going to be equal to 5 squared minus 2.5 square rooted. We're using Pythagoras theorem to find the perpendicular distance H. So 5 square minus 2.5 square. So 5 square minus 2.5 square, and you square root it, that's 4.33. That's the perpendicular distance, 4.33. All right. This T stands for trapezium. All right. So now we can go ahead using the OR method. So OR, realize that the area of the top trapezium is equal to a half the sum of the parallel sides. So it's a half A is 5 plus B is 10 times the perpendicular distance of 4.33. When you stay so and you do that now, you deal with that real quick and you roops it up, you notice that you get 5 plus 10 times 4.33. You divide it by 2, you get 32.475. Now, after you get this now, that's the area of the top trapezium. But remember, it's 2 trapeziums, so the area of the hexagon would just be 2 times this. The area of the hexagon would just be 2 times your 32.475. Why did we multiply it by 2? Because the 2 trapeziums have the same area. And this is going to be approximately equal to 65. All right, so you can either use trapezium or you could use the triangle. Any method you prefer is fine by me, it's fine by CSEC, it's fine by all of we. So this is a trapezium, this is a trapezium. So you could just go ahead and use trapezium rule. Part B, it's a tank of a cross section with dimensions identical to the polygon of EFGHIJ. Water is poured into the tank at a rate of 75 cm³ per second. After 52 seconds, the tank is 2/5 full, so that means it's 40% filled. Determine the capacity of the tank in liter. All right. All right, this looks a pretty nice question. Let's work on this now. So it tells us that this cross section is identical to the polygon around here. So remember, we found that the area of this cross section is already 65 centimeters square. So we can write that down, that the area of the cross section, right here is 65 centimeters square. We know this. All right. Now, after 52 seconds, the tank is 2/5 full. After 52 seconds, the tank is 2/5 full, and water is poured into the tank at a rate of 75 cm³ per second. So for each second, 75 cm³ is poured into the tank. So look at this now. So let's write down that. So 75 cm³ is poured into the tank each second. 75 cm cube is poured into the tank for every 1 second. All right, and so if 75 cm cube is poured into the tank for every 1 second, then after 52 seconds, right, what we're gonna have is 52 times 75. All right, 52 times 75. Tell us how much is poured into the tank after 52 seconds. Because if 1 second go to 75, then how much I got to 52 seconds? It must be 52 times 75. So that unknown that I'm calling X is going to tell us that the capacity that pour into the tank after 52 seconds is 75 times 52. That's all they're telling us. 75 times 52, and that's equal to 3,900 cm cube. 3,900 cm cube. Now, since this is 3,900 cm cube, you divide it by 1,000 to find how many liters it is. You have to remember this, 1,000 cm cube is equal to 1 liter. This is equal to 1 liter. Have to remember that. Don't ever forget it. Store it to your permanent memory. So therefore, this is just 3.9 liters. How do I write liter? I like to write L, 3.9 L. Or you can just write out the word liters. Doesn't matter. So that's the capacity of the tank right now. All right, being 2/5 filled. All right, being 2/5 filled, this is the capacity of the tank. If they wanted how much full to the top, that's a different story, which we could have worked out, by the way. But we know this is just 2/5 of the tank. All right, if 2/5 of the tank is this, we could actually tell them the full capacity of the tank. All right, so if you want to just show off, yeah, go just show off, because you know that this is just 2/5 of the tank. All right, so 40% of the tank is holding 3.9 liters, and so full tank holds, if 40% is 3.9 liters, we need to find out what is 100% of the tank. All right, and so 40% of the tank goes to 3.9, and 100% goes to something. So at 100%, that is going to be equal to 100 times 3.9 divided by 40. So 100 times 3.9, and that's divided by 40, and that's going to be equal to 100 times 3.9 divided by 40. And so it actually can hold 9.75 liters. 9.75 liters is the maximum capacity of the tank. Just some additional stuff. All right. So we know that this small portion right here holds 3.9 liters, but 9.75 liters is the maximum capacity of the whole tank. That means when it will full up to the top. It says calculate the height h of the tank. To calculate the height h of the tank, we already know the volume. We know the volume, which is equal to cross-sectional area times the height. I know the volume is 3,900 cm cube. And we know the cross-sectional area. What's the cross-sectional area? The cross-sectional area is 65 centimeters squared times the height. So the height is equal to, wait, why am I using this? Volume is cross-sectional area times the height. The cross-section, oh, I'm using the wrong volume. We need to use the maximum volume, sorry. The maximum volume or the capacity of the tank, which we found was 9.75 liters, which is 9,750. And so this will give us the height now, 9,750 divided by 65. That will tell us the height of the tank. (9,750) divided by 65, that's 150. That's 150 centimeters. 150 centimeters, they want the answer in meter, and so the height of the tank is 1.5 meter. It's the height of the tank. All right, that's the height of the tank. No issues right here. All right, so again, we wanted the capacity of the tank. We found the capacity when it is 40% filled. So the capacity when it's 40% filled is 3.9. So when it is full up to the tank now, it's going to be 9.75 liters. That's the full capacity of the tank. And if that's the full capacity of the tank, all right, then that's the full volume. The full volume now is area of the cross section, which is 65 times the height. The height is 1.5 meters. All right, so that's it. Very, very, very easy question. No issues.